Question number 11 deals with what? Venturimeter. What is a venturimeter? It's a device used to measure flow. First you find speed. If you know the area of the pipe, if you know speed, then you can find out the volume coming out or volume flowing in a pipe. Notes बंद कर दो. Construction. First the problem. So you have a pipe. In which liquid, say water, is flowing, and you want to measure how much volume is flowing per second. In a petrol pump gas station, you have the total volume, how much fuel you have filled, 4 liter, 5 liter, 6 liters. You can measure volume coming out per second also. So you have a pipe in which water is flowing. Now you want to measure volume of flowing per second. How? If A is the area of the pipe, V is the speed of the pipe, then volume flowing per second is equal to what? Yes, volume flowing per second is equal to A into V. For a given pipe, A is fixed. That means what? The only part left is what? Speed. First part, if you have this arrangement, first you will have to cut it from the two sides. You will have to stop flow of liquid, that is fitment of venturimeter. So you will have to cut this pipe from the two sides and fit in your device. Like you have a pipe and you cut it at the center. Now this part, you fit your venturimeter in between the two. That device is fitted in between the two for measuring what? Speed, and using speed you can find out volume. So up to this point it is the same pipe on the two sides, and now you fit a device. And in this device you have a neck, narrow part, and in this one you have a U-tube type arrangement. What is the purpose? To measure pressure difference. If liquid, say water is flowing in the tube, speed at these 2 points, these are marked as A and B. This is say A, this point is B. Speed at A and B will be same or different? Different. Why? Area is different. As per our continuity equation, area into velocity remains a constant. At this point B, yes, area is less, velocity is more. So that is why there is a pressure difference. So in between the two, under normal condition, if you have a liquid for measuring pressure, it is a liquid different from water. So if at this point pressure is less, the liquid, this blue color is a different type of liquid, and you have this height difference as a H. This part will continue to be water, black color. What is the arrangement? Number one, you have a tube. One area is more in comparison to the other. That means you have a neck arrangement. You have a U-tube, and in U-tube you have a liquid for measuring pressure difference between these 2 points. This liquid, blue color liquid, is different from this black color liquid, say water. This is construction. Time with you is 3 minutes to draw the diagram. Notes band. In construction, what you can write is tube with varying cross section, wider cross section, narrow cross section. In between the two, you have pressure measuring device, which is termed as manometer. The liquid used in manometer is different from liquid flowing in the pipe. Only then you will be able to measure this height. If it is the same liquid, then it is water throughout, then how you measure the pressure difference? No. That is why this liquid is different. Working. Step 1. Continuity equation. Volume flowing per second remains same. Let area at this point be A1 and velocity at A is V1. Area at this point is A2 and velocity at this point is V2. Volume flowing per second is A1 V1 is equal to A2 V2. This is one equation which you will use for numericals. Step 2. Yes, apply Bernoulli's theorem at A and B at these 2 points. Apply. 2 minutes with you to write step 1 and try Bernoulli's theorem at A and B. See, the condition is it should be different. This pressure difference delta P between these 2 points is equal to rho GH. Pressure difference is rho GH. This rho is density of the material, this material. H is the height difference. If the density of this material is less, height is more. If density is more, height is less. The condition is this liquid and this liquid should not mix. That is the condition. You can use a liquid of your type, your choice. The purpose is what? If you want height to be less, density should be more. Question is, why do you use mercury for measurement of pressure? Its density is high. Height of the liquid column will be less. The only condition is this liquid flowing in the pipe should not mix with liquid used for manometer. That's the answer. Practical purpose. I want to make this height as small as possible. Then I will try to make the density as high as possible. You can use a liquid of your choice. Any material given in the lab which you think is convenient, but generally it is mercury. You have questions in competition. Yes. Total energy at A, as per total energy at A per unit volume is equal to total energy at B per unit volume. That is Bernoulli's theorem. These 2 points A and B are at same height. So we shouldn't take up gravitational potential energy. So as in the previous case, pressure plus pressure energy per unit volume, kinetic energy per unit volume. Why not gravitational potential energy? Because A and B are at same height. For point 1, this is density of the liquid flowing in the pipe is equal to P2 plus 1 by 2 rho of liquid flowing in the pipe, V2 square. Is equal to what? Yes, 1 by 2 rho liquid V2 square minus V1 square. You take this term to the right. On left side, what you are left with is P1 minus P2. Pressure difference of the two, delta P, is equal to density of this material, blue color material, density of this blue color material, GH. It is density of the liquid. In this case, these two are different. V2 square minus V1 square. This is equation number 2. Completed. There are two equations. Area. This area is given fixed. For given Venturimeter in the lab, A1 is fixed and written on the board on the specification sheet. A1 is given. A2 is also fixed, given. How many unknown? Two unknown, V1 and V2. So there are two unknown. In this one, rho, density of the material, blue color material, density of this material is also given. Density of the liquid is also given. Suppose this is water, this is mercury. Then this density is how many times? 13.6 times. This value is given. G is known to you, height h. You will measure. If the flow increases, this value h varies. That is why you will have to measure h in every experiment. This is again a constant given value, V2 and V1, again two unknown. So there are two equations, two unknown. You can find out V1 and V2. 2 minutes with you to try. Find V1. There are two equations, two unknown. Step 3. You can put value of V2 here. Density of material GH is equal to 1 by 2 density of liquid. V2 is equal to what? A1 V1 by A2 square minus V1 square. What we have done is, you are giving this value of V2 from equation number 1 and you have to put it in equation number 2. How many unknown are there now? Yes. In this equation, Only thing not known to you is V1. Find V1. 1 by 2 density of liquid V1 square A1 by A2 square minus 1. Find V1. V1 is equal to what? V1 square you can find out first is 2 density of material G H divided by density of liquid A1 by A2 square minus 1. This is what V1 square is. What is V1 equal to? Let this be termed as equation number 3. Step 4. What we want to find out is volume flowing per second. Yes, volume flowing per second to this point is what? A1 V1, and it comes out to be equal to what? You can put this value of V1 here and your answer is equal to A1 into this value of V1. So volume flowing per second. Numerical number 23. Numerical number 23. Numerical number 23 is a Venturimeter is connected to 2 points in mains where its radii are 20 centimeter and 10 centimeter respectively, and the levels of water column in tubes differ by 10 centimeters. How much water flows through the pipe per minute? Yes. Given is what? Radius at 1, how much? 20 centimeter. Radius at 2, 10 centimeter. Radius is half. Area is 1 by 4. This is 1. You can change it to meters. It is, in this particular case, it is given that the pressure difference between the two is 10 centimeter of water column. Yes. Levels of water column in the tube differ by 10 centimeters. Means what? There is another arrangement. You can connect a pipe here and another pipe at this point. So liquid water in this case will rise to different level. So pressure difference here is given in terms of water itself. That is why this value will come out to what? 1. Fine, that's a different construction. It is not this pipe. It is given that pressure at this point and pressure at this point differs. What is flowing is water. What is the pressure difference? In terms of water column only. That is why what you get is volume, you have to find out what? Find volume flowing per second. Yes. In the solution, you apply the same formula. You can put this value, density of the material by density of liquid as 1. What you get is A1 under root 2, this and this are same, G, H. Given is also height of water column. How much? 10 centimeter, 0.1 meters. 2GH divided by A1 by A2 square minus 1. Use SI. A1 is equal to what? Yes, pi r square, but r is in meters, 0.2 meter. R2, 0.1 meter. Density of water, height of the water column, 0.1 meter. 2 minutes with you for calculation. 2 minutes for calculation. First answer in meter cube per second. SI system of units. A1 is equal to pi, yes, R1 square, 2G, 9.8, approximate value 10, H, 0.1 meter, A1, A2, ratio. This ratio is how much? Yes, R1 by R2 is what? R1 by R2. 2 is to 1. A1 by A2 will be 4 is to 1. That is, this value is 4 minus 1 is 3. So, we will get A1 2GH by 3 under root. A1 is how much? Pi 0.2 square under root 2. G is how much? Say 10. H is 0.1 divided by 3. Yes, 10 into 0.1, this is 1. So, what you get is 2 by 3, under root of 2 by 3. Find answer in terms of meter cube per second, SI units. Yes, anyone with the answer, please. And then you can change it to meter cube per second, SI units. Then you can change it to, if you want to match it with the given in the book, 1 meter cube is how many liters? 1000 liter per minute. Here it is 1 second per second. You can change this data per second to per minute. 1 second is equal to what? 1 by 60 minute. In case you want to tell it from the book, first find the answer in meter cube per second. If you want to change it to liter, 1 meter cube is how much? 1000 liter. 1 second is equal to what? 1 by 60 minutes. Confirm it. Anyone getting the same answer given in the book? First answer in meter cube per second. So many meter cube per second. Then 1 meter cube is 1000 liter. 1 second is 1 by 60 minute. Then the answer as given in the book, 2727 approximately. 2726. Yes, you can take it 2727 approximately liter per minute. Yes, anyone with the answer, please? So you can have calculations at home. If there is a correction required, then you can go for the correction also. Numerical number, refer to numerical number 22. Write what is given, what is required. 22, numerical number 22. A venturimeter is 37.5 centimeter diameter in mains and 15 centimeter diameter in throat. The difference between the pressure of water in the mains and the throat is 23 centimeter of mercury. Find the discharge in liters per minute. Specific gravity of mercury is 13.56. What is given is dia at 1, that is this one. How much? 37.5 centimeter. D2, yes. How much? 15 centimeter. Height H is, yes. How much? 23 centimeter. And density of material by density of liquid. Yes. In this case, mercury and water. Density of material by density of liquid in this case is given 13.6, 13.56. Relative density is also given. You have to find out what? Volume flowing per second. Solution. Volume flowing per second. A1. How you find area? Yes. Pi R1 square. How you find R1? This is a dia. Dia is given, radius is half of this. So A1 you can find out. Density of material by density of liquid is how much? 13.56. G 10 approximate. H 23 centimeter. You need to write in meter. All data in SI. You will have to change this centimeter to meter, this to meter, this also meter. A1 by A2. Yes. From this point to this point, A1 by A2, you can find out pi D1 square by 4 divided by pi D2 square by 4. You can find out the ratio of the two. Solve and confirm that the answer comes out to be approximately 8400 liters per minute. 8400 liters per minute. First you will get answer in terms of meter cube per second, as you covered in the previous numerical. You will get answer in meter cube per second. 1 meter cube is 1000 liter. 1 second is 1 by 60 minute. So calculate 2 minutes for calculation. Confirm after calculation. This comes out to be 8400 liter per minute. 8400 liter per minute.